Good morning, physics students, and welcome to another episode of Physics. It's Mr. Finn coming at you, of course, from neighborly Northville. Hey guys, we just have a quick little tidbit today. You were working with generators yesterday. Hopefully you got a little bit of practice with flux, magnetic flux, and what happens when we move things like rings through a magnetic field. So, I'm going to introduce you to something called the Slidewire generator today. It's actually not too difficult of a concept, but we do need to take a few minutes to go through it. Hope you guys are doing well today. And like we've mentioned before, make sure you get into the Google Meets, and if you have questions, fire them into the email, or make sure I get somehow to address them on the video casts that we've been doing. All right, so without further ado, let's get to the big board and look at a Slidewire generator. Hey guys, here we go. We've got the magnetic field. This is a blue circle with a dot in the middle. Now remember guys, our sign conventions are that if you have a circle with a dot in the middle, the magnetic field is coming out at you from the page. Now I've got a kind of a U-shaped metal rod, a metal kind of almost a half a ring, or more than half a ring. And I've got this bar that can run along the surface with contacts. So this bar is free to move back and forth, and the U-shaped case is just fixed. Okay? So this bar is L meters long. We don't know how long it is, just L. Whatever it is. It could be 10 centimeters, 20 centimeters. It could be half a meter. This is delta x. So when we move this bar, this x is going to change as we move the bar. What we're going to try to do is move the bar to the right. So we're going to be increasing the area exposed to the flux. If you guys remember from previous video, your induced voltage is simply a function of the change in magnetic flux over time. Obviously, if we're using more than one loop of wire, we would include more than that N in there. But if we just have one segment, there's no reason to put N in there because N will be 1. Anyway, change in magnetic flux over time. So when we move this bar, just with our hands, just going to slide it to the right. Hence the name Slidewire generator. Well, what is flux? It's B times delta A over delta T, where A is a changing area. Now, B is going to remain constant because we're not going to change the magnetic field. We are changing the area. How are we changing the area? Because delta x times L will be the area at any point in time. But as we move through time, if the bar moves to the right, as time goes on, x will be increasing. X will be increasing as time moves on. Now guys, to go from the next step, you guys might recall, what is delta x over t? We already know that. That's simply velocity. Velocity is delta x over t, change in displacement over time. So you will see a Slidewire generator's voltage written as BLV. Simply by moving along, you are going to create voltage. Now, if you want to figure out how the voltage is going to go, let me stand up to do this. Take my right hand, move it along the motion of the rail here, move it along, curl it towards the magnetic field, which is out towards me. My thumb points down. If my thumb points down, that means that this will be the collection of positive charges, and this will be the collection of negative charges. Hence, there will be a voltage difference between the rails, top and bottom. That's it. Pretty simple, guys. Slidewire generator. And yet, so common, so many applications using a Slidewire generator. Well, you got some practice stuff in your book, guys. I would recommend a few practices, and make sure you get a chance to look at some of those conceptual questions too, about how the ring changes versus the magnetic field, and how the voltage would induce current along. All right, let's wrap up. Well, guys, another note about our chapter that we're in. 21.1 through 21.7 is really all we need. Actually, we don't even need the section on eddy currents. That's just not something we're going to discuss. But we do need the section on transformers, which is 21.7. Other than that, we should be hitting pretty much every other section in that chapter. Take care, guys. If you have any problems, let me know. Otherwise, slide wire generators. Great stuff. We'll see you next time.